Welcome to solverfy.
Hello everyone, today we're doing chapter 19, problem 26. This problem gives us the ball and stick models of two molecules, A and B, and asks us a few questions. So first it asks us to draw or give us the IUPAC names for each of these compounds. So let's start with the one on the left. So we see that we have 1, 2, 3, 4, 5, 6 carbons being the parent chain. So we know that 6 carbons is hex. The straight carbon chain would be hexane, but we have a carboxylic acid at the end, so we know it's going to be oic acid being a suffix, so hexanoic acid. And then we have to add the substituents to in the front of the parent name. So the carboxylic acid carbon being carbon number 1, we have 2-methyl, 3, 4, 5-methyl. So we have a 2,5-dimethyl hexanoic acid. And now for B, we see that we have a cyclohexane, but we also have a carboxylic acid on it, so cyclohexane hexanoic acid. And then on carbon, the carbon being carbon having the carboxylic attached to it, that would be considered carbon number 1. So if we count from here, making these substituents have the lowest rankings, we have 1, 2, 3. So on carbon 3, we have 2 methyl groups. So we have a 3,3-dimethyl cyclohexanoic acid. So now in B, it asks us what product is formed when each compound is treated with NaOH, so sodium hydroxide. So we're adding a strong base. NaOH. NaOH. So strong base is obviously going to deprotonate your most acidic proton, being the carboxylic acid proton. So we're just going to form the conjugate base of this molecule. And same thing goes for the B. And then in C, it asks us to name the products. So the name doesn't change, so we can literally just copy paste the name. But now what we need to do is that this is no longer an acid. This is the conjugate base of the acid. So we need to be very specific about that. This is negative charge. These are negative charges. So we need to be very specific that this is no longer an acid. This is the conjugate base. So because it's a conjugate base, we know that the conjugate base has a suffix of 8. So hexanoate. So we lose the oic acid and we add the O8 suffix. So the same thing goes for B here. So same thing. We lose the hexanoic acid and we add hexanoate. And now last but not least, this asks us to draw the structure of an isomer that is at least 10 to the 5 times less acidic than each compound. So an isomer must have the same number of carbons, hydrogens, and atoms, but it can differ in bonding. So something that would differ 10 to the 5 times in acidity, well, we can lose this acidic proton. So if we lose this acidic proton here, our molecule, both of these are going to be highly non-acidic. So if we just lose that acidic proton by adding one of these methyl groups over here, like this, we now made this molecule a lot less acidic because there's now no acidic proton. There is an alpha proton here, but it's nothing compared to this carboxylic acid proton. So we significantly just decreased the acidity of this molecule. Same thing goes for here, and in fact we can even add this methyl group over here, so there would be inductive donation of electron density, which would even destabilize the conjugate base, making this less acidic.